Welcome, ladies and gentlemen, to this new episode of What I Would Like to Be. Today we are going to interview two chemists who are working in the forensics area. So first of all, I will let Alize introduce you forensics chemistry.
Hi Melissa, so as you said, we are going to meet two forensic chemists. You've all seen episodes from CSI, Crime Scene Investigation, with the charismatic Horatio Kane, played by David Caruso, or from NCIS, Naval Criminal Investigative Series, with Abby, played by Paul Perez. So as seen on Court TV, forensic chemists are often called upon to explain what was found and how they arrived to their conclusion. However, does this series represent the work of a chemist in an investigation lab?
That's the question we are going to ask to Morgan and Maud, who are working for a CSI department. We can name the lab for safety reasons that you surely understood. But first of all, a little history part.
So the history of forensic chemistry finds its beginning in 82 before Christ, when Democritus studied poison and shared his findings with Hippocrates. During the time of the Romans, understanding poison was vital, as poison was the weapon of choice for murder and execution. It was only in 1752 when actual forensic science was applied. During the Blandy trial, the court requested for a test in arsenic poisoning. This was followed by the development of Marsh test, which was the first reliable test that proved arsenic was present in the body. Forensic chemistry is a vast and interesting field of chemistry, which does not only entail working in the confines of a laboratory. The expertise of a forensic chemist is valuable, as it can determine whether a man is guilty or not. A forensic chemist must have the analytical mind and the disciplined focus to ensure that no information is overlooked and that evidence is evaluated thoroughly. A case cannot be built and justice cannot be served with 40 investigations.
Alright, thanks Alize. So let's go and meet our two guests of the day. We are now meeting Maud. I hope we won't disturb her. Hi Maud.
Hi.
Can you explain us first of all what is the work of a forensics chemist?
A forensic chemist is a professional chemist who analyzes evidence that is brought in from crime scenes and reaches a conclusion based on tests run on that piece of evidence. A forensic chemist's job is to identify and characterize the evidence as part of the largest process of solving a crime. Forensic chemists rarely conduct any investigative work. They handle the evidence collected from the crime scene. Evidence may include hair sample, paint chips, glass fragments, or blood stains. Understanding the evidence requires tools from many disciplines, including chemistry, biology, material science, and genetics. The prevalence of DNA analysis is making knowledge of genetics increasingly important in this field.
And could you describe your everyday work?
Of course. Forensic chemists apply knowledge from diverse disciplines such as chemistry, biology, material science, and genetics to the analysis of evidence from at crime scenes or on or in the body of crime suspects. The field is a combination of criminalistics and analytical toxicology. Criminalistics is the qualitative examination of evidence using methods such as microscopy and spot testing, whereas analytical toxicology looks for evidence in body fluid through a range of instrumental techniques, from optical methods like UV, infrared, X-ray, to separation analysis like gas chromatography, HPLC, and single-layer chromatography. Mass spectrometry is also frequently used since it provides the strongest evidence in court. Most often, forensic chemists don't know the nature of the sample before they analyze it. The results of their work are used in police investigation and court trial, at which they may be called upon to provide expert testimony and explain their findings to a jury.
I've made some research for you to explain what those techniques are. High-performance liquid chromatography, or HPLC, is a chromatographic technique used to separate a mixture of compounds in analytical chemistry and biochemistry with the purpose of identifying, quantifying, and purifying the individual components of the mixture. Some common examples are the separation and quantification of performance enhancement drugs, like steroids, in urine sample or of vitamin D levels in serum. You have there an example of HPLC, quite different from the one you can see in CSI, isn't it? Mass spectrometry is an analytical technique that measures the mass to charge ratio of charged particles. It is used for determining mass of particles, for determining the elemental composition of a sample or molecule, and for elucidating the chemical structure of molecules, such as peptides and other chemical compounds. It works by ionizing chemical compounds to generate charged molecules or molecule fragments, and measuring their mass to charge ratios. Mass spectrometer can be divided into three fundamental parts, namely the ionization source, the analyzer, and the detector. The sample has to be introduced into the ionization source of the instrument. Once inside the ionization source, the sample molecules are ionized because ions are easier to manipulate than neutral molecules. These ions are extracted into the analyzer region of the mass spectrometer, where they are separated according to their mass to charge ratios. The separated ions are detected in this signal, sent to a data system where the NZ ratios are stored, together with their relative abundance for presentation, in the format of a NZ spectrum. The analyzer and detector of the mass spectrometer, and often the ionization source too, are maintained under high vacuum to give the ions a reasonable chance of traveling from one end of the instrument to the other without any hindrance from air molecules. Am I right?
Perfect! You may have done a good forensic chemist.
Now let's go find Morgan, who will explain us procedures and show us the equipment in the lab. Here you are. Hi Morgan.
Hi!
So chemists are not the only person working in the lab. Can you show us some equipment, please?
Yes, of course. So the equipment in the forensics lab is always changing due to standards that are always rising due to new exciting technology. Most forensic science labs have trace evidence units where they will have many different high-powered microscopes that will allow them to enhance evidence such as hair, fabric, fibers, dust, and even skeletal remains. High-powered microscopes are used along with slides and sometimes even chemicals that can enhance an item to allow the scientist to see it better. Chemistry is a standard part of the job for a forensic scientist, so chemistry sets are usually found in a lab, as you can see around me. Chemistry sets are used to test samples that come into the lab such as blood and urine, drugs, and even toxins. Chemistry is also used to identify and test medication, dyes, stains, and more. Some of the particular items related to chemistry that you may find in the lab include gas chromatography and mass spectrometers. In addition, fume cupboards may be used in forensics labs. Serology is an important part of forensic science labs, where it is commonplace to see a variety of machines in the lab that will allow for the scientists to identify and analyze blood and other bodily fluid. These machines can also help with DNA sequencing, which is often done by polymerase chain reaction capable machines. Polymerase chain reaction can be done in almost small laboratories, but bigger laboratories will also be able to supply the machines and tools necessary to analyze mitochondrial DNA. Many forensic science labs have firearms test units as well. They are basically big tubes that are set up that can be safely fired into. This will allow specialists to take the shell casing of the bullet as well as the bullet and compare it to evidence via a microscope. Firearms related forensics has come a long way in the last few years, and many of the forensics labs are very excited about this advancement. Computer, audio and visual equipment and more electronic equipment is found in forensics lab. This can be used for a variety of reasons and are made available to the scientists as they often call of them for the many different forensics and investigations.
And so what is the exact procedure when evidence is brought to the lab?
So when an evidence is brought back at the crime lab, like suspicious material, DNA, or leftover accidents in arson case, CSI techs have a closer look using methods derived from forensics chemistry. This high CSI television series actually portray an almost accurate practice of the procedure they use in real life crime lab. Basically, when a suspicious compound are recovered and brought to a crime lab, a few scientific procedures are strictly followed. So this procedure includes gas chromatography, mass spectroscopy, and lastly a procedure called infrared spectrophotometry. Gas chromatography is used to separate a compound mixture into its individual parts. It does this by identifying the compound and how far its parts can move through an inert and noble gases. Using forensic chemistry techniques, mass spectroscopy is used to develop the technical buildup of a substance. This is highly effective since substances with exactly the same chemical buildup do not exist. These methods can actually work in unison using a combination called gas chromatograph mass spectrometer, by which the GC part forces the gaseous substance into a mass spectroscope apparatus that can verify the mass spectrum of the substance in question. The combination can identify just about any substance existing today. The last technique is called infrared spectrophotometry, so you have an example over there, and can determine the results of a chemical fingerprint analysis by keeping track of the amount of infrared light existing or absorbed in the suspicious compound. With forensic chemistry skills, all substances are tagged and identified by its parts. Since the exact origin of or manufacturer of the compound is in question is not easily determined even with advances in forensic chemistry, tracing a mysterious sample to its origin, like hardware stores or gas stations, must require comparison and others taken from suspected origins. Although this kind of analysis is entirely accurate, the purpose is to find possible sources that investigators will focus on. Oh, sorry, I've got a call phone. Hi. Okay, I'm coming. It was the police. I have to go and see a crime scene. Bye.
So, Maud, why are we meeting here for the end of our emission?
Because you have forgot an aspect of our job. We have to explain and defend our results. Forensic chemists agree that public speaking skills and being comfortable with what you do are important personal characteristics for this career. As seen on Court TV, forensic chemists are often called upon to explain what was found and how they arrive at their conclusion. Not all cases go to trial, but when one does, giving expert testimony in court is a significant piece of a forensic chemist's job. Some employers require their forensic chemists to go through several months of mock courtroom testimony training along with their regular training. Forensic chemists must be able to give an impartial explanation to the jury that will assist in the final judgment. Forensic chemists analyze the evidence but don't determine the verdict.
Okay, thank you very much, Maud and Morgan, for presenting us your unusual job. Thanks for watching and see you next week for a new episode of What I Would Like to Be on ABC.